Einstein could prove theoretically a possible equivalence between gravity and acceleration only for linear acceleration. In his work in 1907, where the principle of equivalence appeared for the first time, he liked to use the generic word acceleration, but the calculation concerned only uniformly accelerated translational motion. So it was with the derivation of the formula for time dilation. He considered two reference systems, one at rest and one accelerated relative to the first along the x-axis. The result was transferred to the reference system in the gravitational field. Experimental confirmations, however, use the centrifugal acceleration generated by the rotation. Such experiments are about the equivalence of heavy and inert masses. It is often referred to as the weak equivalence principle. First measurements took place in the 19th century. With the torsion balance, gravity and centrifugal force were compared. Last came from the Earth's rotation. Modern measurements with the satellites improved the results of that time. The gravitational acceleration was even completely compensated by the centrifugal acceleration. This is a clear case of generalization, which is very common in theoretical physics. For that, experimental refutation has long been there. Hafel's experiment is the best-known experiment for the registration of relativistic time dilation. In 1971, the aircraft flew with several atomic clocks on board around the Earth, sometimes in one direction, sometimes in the opposite direction. The measurement result was in accordance with a theory. The speed of the aircraft and the weaker gravitational field at altitude were considered, but not the centrifugal acceleration of the aircraft. Does the centrifugal acceleration contribute nothing to the time dilation? Right. One can also assume that the effect was very small, so it is not mentioned in reports. However, quite large centrifugal acceleration occurs in the particle accelerators. In 1977, CERN achieved approximately 30 times the lifetime of fast muons. The particles moved in the storage ring with the diameter of 14 meters. The centrifugal acceleration was an incredible 10 to 18 g, or a billion times the acceleration on the Earth's surface. Nevertheless, no influence of gigantic centrifugal acceleration on the lifetime of the muons was found. So the physicists have known about it for a long time, but continue like in the 19th century. In the experiments, the gravitational acceleration is compensated by the centrifugal acceleration. But is it possible that the gravitational field has no influence on the clock? However, there is much experimental evidence for time dilation by gravity. Recently, the measurements were made with a positive result in the Alps using a portable atomic clock. Let's be clear, the gravitational field slows the clock. The centrifugal acceleration, however, has no effect on the clock. In the meantime, the last one can completely balance out the first, so that Einstein's assumptions concerning the principle of equivalence are completely fulfilled. To what extent can the frame in the gravitational field and the frame accelerated by the rotation be equivalent? Obviously, not at all. The experiments demonstrating the equality of heavy and inert masses cannot serve as proof of Einstein's equivalence principle. Conversely, they really show how weak, in the direct sense, is the principle of equivalence. The only hope, even the smallest, is linear acceleration. According to Einstein's calculation, it should certainly cause time dilation. But real evidence is not known. Otherwise it would have been strange. From the perspective of the orthogonal coordinate system, the rotational motion of a body has stronger acceleration times along the axis x times along the axis y. That is, the centrifugal acceleration can be described as a combination of two orthogonal linear accelerations. And there is no time dilation. In short, the equivalence principle of Einstein is a fiction.